Hi, this is Dr. Du. In this video, I'm going to use an example to demonstrate how GeoGebra can be used to calculate the linear correlation coefficient. Let's get started. Here, this table shows data collected from 10 randomly selected people. From each of these 10 people, the number of years of school and the score on a test measuring prejudice are recorded. For example, the first pair of data on person A is 12 and 1, meaning this person had 12 years of school and his or her score on the prejudice test is 1. In this example, X represents the number of years of school and Y represents the prejudice score. We want to determine the correlation coefficient of these two variables. Start typing in each pair of data in the input bar. For example, the first pair, open parentheses, 12, then 1. Hit enter to finish. Repeat this until you entered all your pairs. Every time you enter the other pair, the pair is named and a point that corresponds to this other pair is plotted in the graphing area. Once you finish typing all your pairs, you will obtain the scatter plot of the data. Once you have all the data typed in, then in the input bar, type the GeoGebra command correlation coefficient. So C-O-R-R. So as you can see, you don't have to type the whole command in. After you type the first few letters of the command, it will appear and it will show you what argument the command needs. So if you choose the first choice, it's gonna need a list of points. Okay, so let's choose the first one. So what we are going to put in now is the name of the points we entered here. So let's do that. So I'm gonna delete all this and I'm gonna start typing in my point. So A, B, C, D, E, F, G, H, I, and J. And so once you finish typing in the last point, as you can see on the bottom of this input bar, the correlation coefficient is already being calculated for you. So it is negative 0.92. So as you can see, the value of the correlation coefficient and the scatter plot both indicate, the variables X and Y has a negative correlation. The correlation coefficient command can also take in the X coordinates and the Y coordinates separately and return the same answer. So let's try that. C-O-R-R, and we choose the second option. Okay, so let's make this bigger. Okay, so as you can see, they need two arguments. One is the list of X coordinates, so basically the X values, and then the Y values. So let's start with the X values. So get rid of this. And you have to put the list of X values in a pair of curly braces. So start with this, and we have 12, 5, 14, 13, 8, 10, 16, 11, 12, and 4. Okay, and then for the Y, I'm going to do the same thing. So braces, okay, and then 1, 7, 2, 3, 5, 4, 1, 2, 3, and 10. So that's the last number. So hit enter. So as you can see, they both give us the negative 0.92. So basically this is just another way to calculate the correlation coefficient. Personally, I like the first way to do it, because not only it calculates the linear correlation coefficient for you, it also shows you the scatter plot.